Hey everyone, welcome back in this video. In this video, we are going to talk about another operation on sets, just like the operation of union, intersection, complementation, or difference of sets. So we have, besides the operations of union, intersection, complementation, or difference of sets on sets, we have one more operation, namely Cartesian product, or simply we can call it product of sets. You should note one more thing at the very outset of the video, that is, Cartesian product is nothing but an operation on a collection of sets. So here is the definition of Cartesian product of two sets. Note down first of all that you can generalize this definition to any number of sets. You can consider a finite collection of sets and take their Cartesian product. You can even take the Cartesian product of countably infinite family of sets. So here is the definition of Cartesian product, but for two sets. Here we go. Given two sets A and B such that A and B are not empty, then A cross B is a new type of set and is defined as the set of all the objects of the form written like this way, such that A is an element of this set and B is an element of the set B, capital B. This definition tells me that if I have two sets A and B such that both of the sets A and B are not empty, then their Cartesian product, which we denote by this symbol, and we read this symbol as A cross B. And A cross B is nothing but a new type of set whose elements are ordered pairs. So this expression defines the concept of Cartesian product of two sets. Now you should note or observe something about this definition. A cross B is nothing but a set whose elements are ordered pairs. Now in this video, I'm not going to tell you what is an ordered pair because I have already discussed this issue. And you know, ordered pairs have a very fundamental or characteristic property. A cross B is nothing but a set. Now, if it is a set, the question arises, what are its elements? Its elements are ordered pairs. Note second tells me that if at least one of the sets A and B is empty, then A cross B and B cross A are both empty. Means that if among the given sets A and B, you have at least one, in some cases you can have both of the sets empty. If at least you have one set which is empty, then their Cartesian product will be empty. Point third says me that if A or B, or is used here in the inclusive sense, you should note down here. If A or B means that if at least one of the sets A and B is infinite, then so are A and B. Means that if A and B are infinite, at least one of the sets A and B is infinite, then A cross B and B cross A, both of them will be infinite. Now, the important note, which is fourth one, which says us that in general, A cross B is not equal to B cross A. Why? Now, let's consider this example. In this example, I have two sets A and B. The elements of the sets are displayed, and here they are. Similarly, I have set B, whose elements are 7, 6, and 5. Now, I want to know what is the Cartesian product of A cross B. Simply, I will apply the definition to this particular case and see what we will get. Now, as you can see from this definition, A cross B consists of the ordered pairs A and B, where A belongs to the set A and B belongs to the capital set B. It means that in an ordered pair AB of the Cartesian product A cross B, the first element of the of the ordered pair AB comes from the set A, and the second element comes from the set B. So I want to calculate the Cartesian product A cross B. So applying the definition, I get this very set. As you can see, if I also calculate the Cartesian product B cross A, we get this very set. Now apply the definition of equality of two sets. You will get that A cross B is not equal to B cross A, because recall the definition of equality of two sets. Two sets are said to be equal if they have got the same elements. I mean, one is the subset of another. So as I have found at least one elements in these two sets A cross B and B cross A which are not equal, if I am able to find such an element, I will say that A cross B is not equal to B cross A. Because recall, when two sets are not equal if one is not the subset of another. It means that if you find at least one element in one of the given sets which is not present in the other set, those two sets are unequal. Now as you can see, 0, 7, the ordered pair 0, 7 belongs to the set A cross B, and I have another ordered pair which belongs to B cross A, but it is 7, 0. And we know by applying the definition of equality of two ordered pairs, we know 0, 7, the ordered pair 0, 7 is not equal to the ordered pair 7, 0, because by the nature of an ordered pair. So here I have several objects in these two sets, A cross B and B cross A, which are not equal. So it implies that A cross B is not equal to B cross A. So here I have example in which we have A cross B which is not equal to B cross A. Now let's consider another example. In this example, I have two sets A and B, and fortunately, or you can say deliberately, I have taken this case where A and B are equal sets, as you can see yourself. So what will be the Cartesian product A cross B? It will be this set. After applying the definition to this very particular example, my A cross B is this set. Now, if you apply the same definition but to B cross A, you will get the same thing, the same set. Now, you should note here in this example one particular thing. That is, we have A cross B equal to B cross A if A is equal to B. In this case, as you can see yourself, and it is given that A is equal to B, and it implies that A cross B is equal to B cross A. So in this example, I have A is equal to B, and I have deduced that A cross B is equal to B cross A. Now I have a question. Can we generalize this particular statement? I mean, what will happen if I try to generalize this particular case to an arbitrary set? That is, if A and B are arbitrary sets such that A is equal to B. Now in this case, I don't have these two sets. I am taking arbitrary sets. They could be any two sets. So if I have two sets and it is given that those two sets A and B are equal, can we generalize that A cross B is equal to B cross A? Check it out and work it out yourself. Now I have some examples here, and my first example consists of these two sets A and B, and these are the elements of the set A, and these are the elements of the set B. And after applying this definition to this particular example, I get A cross B like this. And this is the Cartesian product A cross B of the sets A and B. Now here is another second example. And in this case, the set A is empty, I mean phi, and the set B consists of these elements. And as you can see, A cross B is equal to phi cross A, which is the empty set itself. Why A cross B is equal to the empty set? Simply because an ordered pair consists of two objects A and B. But in this case, one of the sets is empty. It means that you can create an object whose one of the entries comes from the set A, but I'm not able to put any entry from the set phi because it is empty. So it is not possible to make ordered pairs from this operation, or after applying the operation of Cartesian product to the situation where one of the sets is empty. So that is why A cross B is equal to the empty set. Now consider another case. Note that in this case, one of the sets is infinite. So what will be the Cartesian product of two sets in which one of the sets is infinite? As you can see, my first set is the set of natural numbers, and we know that the set of natural numbers goes endlessly. So, and the second set consists of these elements. Obviously, as there are infinitely many choices in this set, implies that there are infinitely many possibilities of ordered pairs, which are the elements of the set A cross B. So A cross B is infinite. Why? Because one of the sets is infinite. Why so? Because there are infinitely many choices for making ordered pairs. Thanks a lot.